Hey, good morning. I just want to take an opportunity to answer some of your questions. On assignment 90, we had somebody asking about those graphs. I just want to pick a few of them. And so basically the deal is with graphs. Let's take a look at number 11. Useful things for you to be able to find on that in your process of graphing. First of all would be your y-intercept. And the y-intercept comes from this number right here, because when you plug a 0 in here, that gives you your y-intercept in any xy chart. So when I plug a 0 in, it gives me a 3 right there. So just in terms of a very rough graph. Okay, you would put a x and y. So your y-intercept would be 3. We are expecting it to be a growth function because this one is greater than 1, so we're expecting it to be going up exponentially. And then you should pick one other point to be able to do that. And I'll expect you to do one other point. So you could pick something like plugging in a 1. And in this case, this would give you 6. So here's 1, 1, 2, 3, 4, 5, 6. And you could put your other point in here and then swoop it down. Or you could even pick a -1 if you're comfortable with that. That would give you 3 halves, or 1.5, which would bring us here. I only need you to have the y-intercept and one other point for your graphs, but then keep in mind under normal circumstances it's going to be approaching the x-axis. And what do I mean normal circumstances? I'll get another one in a minute. And that will be a perfectly acceptable graph for you to show. Now, I did say something about under normal circumstances, so let's just take a look at, let's just look at this other one here. Trying to find a good example. It's not one right here. I'm just going to turn the page here and look at some others. Oh, wait, before we go on that one. Let's look at 15. Y equals 2 to 3 halves to the x power. Once again, your y-intercept comes from the number that's out in front of the exponential part, so there would be your y-intercept. And you put the graph on like this. So 2 would be one of your main points. And then the other one, if I took, so 0 would give you 2, 1, 2 times 3 halves to the first power, 2 times 3 halves would give you 3. Okay, so that would be right here. Okay, and then it would be coming down like this. Now, for example, though, if we had one that was smaller than 1, like number 17, 17 is actually fantastic. Let's take a look at 17. Y equals 5 times 1/3 to the x power minus 8. What makes that fantastic is it's got a whole bunch of things happening. There's your would be your y-intercept, but everything is moved down 8. Okay, so we've got to be careful with there. There would be your y-intercept, but everything is moved down 8. So 1, 2, 3, 4, 5, 6, 7, 8. It would have been at 5, but this minus 8 moves it down 8. And if you don't like that because this thing out here really messes you up, you can always find your y-intercept by plugging a 0 in. So 5 times 1 minus 8 gives you -3. So in other words, it would have been at 5, but then it moved down 8 to -3. And then you can pick one other point. Okay, you could pick 1, or you could pick whatever that point is. 5 1/3 to the first power minus 8. This would give you 5/3 minus 8, which would give you 5/3 minus 24/3, negative 19/3, negative 6 1/3. So here's your 1, 2, 3, 4, 5, 6 1/3 would be about here. Now the thing is that you notice that it's going downward. Why it's going downward is because this is a fraction. This part being a fraction that's smaller than 1 tells you that this is a decay function rather than a growth function. So that makes sense. You just have to be careful. Since it moved down to 8, when you're graphing, you have to make sure to bring it down, but then don't pass the -8 line, and I would be looking for that as well. If you're looking at question number 33 in the book, it's asking you to figure out which the transformations are, and with the part that's attached to the x, that tells you left 2, and then the 1 tells you up 1. And so there is the one that attaches to the x goes left and right, and the other one goes up and down when you're looking at that problem. Graphing calculator, we didn't use the calculator really at all on this, so you don't have to worry so much about 35. If you did want to do that, make sure that you would include the parentheses in it. Since you asked, we can bring this in here for you and just do it. So what I have here is y equals, let's start with just one of them. There's a whole bunch of them here, but 1/2 to the x power. The x is right here, 1/2 to the x power. And then you could zoom 6 the thing again and take a look at the graph. Now, really, honestly, that goes with exactly what we had been talking about anyway. You probably had a picture in your mind ahead of time with what that would look like. It says, explain why the definition of exponential functions has the constraint that b cannot equal 1, and b couldn't equal 1. That would be the number that's taken to a power, because 1 to any power is just 1 anyway. So it wouldn't end up being a curve. It would end up being a straight line. So that would be your reasoning for that one. Let's take a look at 41. 41 is just giving you an equation that's in terms of something that is more practical. They give you the equation P equals 101.3 e to the negative 0.001, and then they give you an h value of 500. Okay, so what you can do with this one, the e value is hiding in here, right here, the shift of the ln. So you can put in your 101.3 times e to the negative 0.001, we can do this all in one step, times 500. And you end up with your answer and getting the thing that you're supposed to get on that. Don't let word problems fool you. Usually they're just putting a whole bunch of words around a thing. They gave you the formula and told you which, so you can just use that. Okay. All right, and the next one I see that isn't strictly review goes with the Pert formula for the continuous compounding, but they said you want to have $8,000 after 4 years at 6% interest rate. So do for this one, P is your only variable here, so you need to calculate so once again, you've got e to the x power, which is 0.04, 0.06 times 4. P equals 1.2, P times 1.27 equals 8,000. So you would just divide both sides by 1.27 to get that one by itself. So 8,000 divided by 1.27, and we get about $6,300. I did do a little rounding there, so about $6,300 to get that interest rate returned to you. Okay. And then we'll move on to the next assignment, which was number 91. Well, we're going to combine your questions from assignment 91 and assignment 92. Now, the first couple questions that were asked, and I'm just going to do one of them because they're really the same question. And it said to write it in logarithmic form. Don't forget, this is your base, this is your exponent, this is your number. So for this one, it would be log base 3 of 243 equals 5. Because a logarithm 3 to this power equals this number. So you're able to rewrite in that way. I had questions also on 15 and 17 and 19 as well. So if we had this one and it looks a little bit stranger here, 10 to the negative first. If you want to do this, here's your base, here's your exponent. Log base 10 of 1/10 equals -1. Okay, your logarithmic form for all of them, okay, is here's your base, here's your base. Your exponent is your answer. Okay, a logarithm gives you the exponent, and then this is the thing. 10 to the negative first power equals 1/10. So these are really all the same questions. 15, 17, 19. You're mutating it into the form where you've got it in logarithmic form. All right, there are questions on 37 and 39. Both of them were graphing equations. So we're back to that again. 37, y to the 2x power. You're thinking about, first of all, what your y-intercept is. Okay, on all of these equations, we want to be looking for your intercepts, y-intercept. So here there's really nothing out front, so that makes your y-intercept 1. once again, you can always plug in a 0 for x to find your y-intercept, just like you did way back in Algebra 1. So there's one. I want you to have at least one other point to show shape. 1 here, 2 to the first power is 2. So you would graph that, coming down so that it does not cross the x-axis. The only time you shift that so that it's at another place where it bottoms out would be if there was a number out here. Okay, 39 is just like it. It would have a y-intercept of 1 because it's another number to the half power, to the exponent. But in that case, since it's a half, it would be decreasing. It would be a decay function rather than a growth function. So we have those things. Okay, so just so you can see number 39, because there were a couple people that specifically wanted that one. 1/2 x power, once again, your y-intercept is 1. Because when x is 0, 1/2 to the 0 power is 1. If I wanted to, I can plug in a 1 here. 1/2 to the first power is a half. So there would be your half. And you're coming down like this. And it's a decay function. 47, 49, those 47, 49, 51, that type, and 53, they want you to write it in exponential form. They are all the same question with different numbers in it. So let's pick number 51 to start with. Okay, I know that I'm jumping around, but since some of them are an entire section, if you can get one of them, you can get them all. Okay, so writing in exponential form, this is the base, this is the exponent. That's exponential form right here. Base, power, answer. So that's exponential form. 53 has its own other issue, so I'll do that one. When there isn't a base written, remember it is a hidden base 10, so this would be 10 that's hiding to the first power equals 10 here, and there's your exponential form for that one. Now for questions number 55 and 57, it's asking you for the greatest integer that is less than the value of the logarithm. So just, you can do log base 10 on your calculator. So we have this log of 0.08. It gives you this number, but it says they're asking for the greatest integer that is smaller than this value, which just means that you go wherever this is, you go down 1. So this would be at -2. The greatest integer that is smaller than this would be just plain 7. I know it's a strangely worded question, but that's all they're asking you to do there. Okay, then on 59, this is the same question as this, just with more stuff to look at. So you have 2x plus 1 is your base, 5 is your power, and a plus b would be what goes on the other side. So same problem as this, just making it look a little bit more difficult for you. 61, inverse functions. So we look at inverse. You have on that one y equals log base 4 of x. Remember, for inverses you switch. Log base 4 of y. Then you need to solve for y, so write it in its exponential function. 4 to the x power equals y, and that one's actually done. So that's 61 as far as how to get that one under control. And then the last one was 71, which was a graph, and there was a couple of you that wanted to look at that. So let's look at that one. y equals log base 4 of 2x plus 3. Okay, and this one is the trickiest of all the things that anybody asked, but let's just think about this a little bit backwards. Let's think about this in exponential form. This is 4 to the y power equals 2x plus 3. So this one is super challenging. I'm not going to test you or quiz you on it, but it's a good thing to always be able to think through a new scenario. If, for example, if we want to get our general shape on this, we would kind of work backwards just a little bit. So if we have y being 0 and then we go backwards, so 4 to the 0 power equals 2x plus 3. So that would give you 2x plus 3. So 2x equals negative 2 when we subtract 3 from both sides. So x would equal negative 1. There will be 1 that would be helpful to us. Then instead of plugging in for x, plug in for y because they're way easier to solve for. So we're going to take 4 to the first power equals 2x plus 3. So 4 minus 3 is 1 divided by 2, so we have a half. Remember, this is the inverse of the exponential function, so we're kind of expecting it to behave like that. So when we graph this thing, okay, negative 1, 0, and we have 1/2, 1, like this. If you're still not quite sure of the shape of this, you can always plug in another value and see what's happening afterwards. So we could plug in a 2, for example. So we get 4 squared equals, oops, a 2 in the y, not a 2 in the x. Two x plus 3. 16 equals 2x plus 3, so 13 equals 2x. X is 6.5. One, 2, 3, 4, 5, 6.5 is right about here. And that would give us where 2 lives. That would be up here. So what we see is we see this thing happening. Here's our graph like this. We can imagine that we would then be extending down this way, and this would be a good graph for you to have on this one. Okay, so there we have it. There's our different questions that you had asked on these things. I hope that helps you out as far as whatever it is that you needed to understand a little bit better. All right, I hope that you're going to do great on this quiz. I'm praying for you that everything's going to work out well for you, and have a really great day. God bless.